Okay, so here's an example problem on loss budgeting, and this is a problem that's going to uh, be a lot like one of the homework problems, and so I hope it helps. Basically, in this problem, let's suppose that we're given the receiver sensitivity is minus 75 dBm, and that the loss of the channel is given as L is say 60 dB, and we can label the receiver sensitivity as P min in dB units. Okay, because the receiver sensitivity is by definition the minimum received power for the system to work properly. That is, to give an acceptably low bit error rate. Okay, and in part A of this problem, I will ask, what is the minimum? Find PTX minimum. That is the minimum received, or the minimum transmitted power. Okay, and the minimum transmitted power occurs when the loss of the channel takes you down exactly to the minimum received power. So I could call this P min Rx, or PRX min here, to make it look like PTX min. So basically, as a power scale, on a decibel power scale, we've got PTX and we've got PRX min, and we have the loss of the channel between the two. Okay, and when the received power is equal to the minimum received power, then that is the minimum transmitted power. Okay, and so in general we can write P transmit minus loss is equal to P receive. And in this case we're going to write PTX minimum minus the loss is PRX minimum. And so we're going to say that the minimum transmitted power is equal to the PRX min plus L. So I've just solved this equation for PTX min. And basically the algebra comes down to minus 75 plus 60, giving you minus 15 dBm is the minimum transmitted power. Okay, and that would, by the way, leave you with what's called a system margin of 0. In other words, there's no margin of error. The channel loss can't go up at all, or else you're going to lose your channel. Okay, in part B, what I'll do is I'll go ahead and say suppose, or let PTX be negative 10 dBm. Calculate the system margin M. Okay, and now we've got a situation where we have PTX, we have PRX, and hopefully where our received power, PRX, is above our minimum received power, in which case our margin M is going to be positive. Okay, and of course this is the loss of the channel here. Okay, and so we can write the equation that PTX minus L minus M is equal to PRX min. Okay, equivalently we can write PRX minus PRX min is equal to the system. Oh, sorry. Another way of saying this is that PRX minus PRX min is equal to the margin M. Okay, and so, but PRX is PTX minus L. So these are basically the same equation, and I can go ahead and write that. I'll have to catch that later. I will go ahead and calculate the system margin by solving for M here. Well, here I've solved for M. P received is P transmitted minus the loss of the channel, and then minus PRX min. And this is equal to the transmitted power minus 10 minus 60 minus negative 75, and that gives me, let's see, negative 70 plus 75 is 5 dB. And you could have seen this immediately, I hope, in that if we had negative 15 dBm of transmitted power, we had a system margin of 0. But here we're going to have negative 10 dBm of transmitted power, which is 5 dB up. Keeping the same sensitivity gives us 5 dB of system margin. Okay? If we were to raise the transmitted power to negative 5 dBm, we'd have 10 dB of margin. So this one's very similar to one in your book. I hope this helps. Thanks for listening.